So for this video, we're just going to be looking at further index notation. Now this really doesn't include anything that's new. It's really no new information. What you're doing is looking at the index laws and the notation you already know, but looking at a few tips and tricks and a few ways that the questions could be presented a bit more sneakily if you would like. So let's look at a few examples of how this could be done. The first example we're going to go through is b to the power 7 times b to the power -2. Now, a very standard question that involves the laws of indices, and when we multiply, we know that we add our indices. The thing to note, however, is that here I will be adding 7 plus a -2. Adding a negative is where the quote-unquote trick might come into play. So here we have b to the power of 7 minus 2, which is really b to the power of 5. So don't be fooled in thinking that we'll be multiplying, therefore adding our indices, therefore the number has to get bigger. Sometimes those indices could be negative numbers. Let's look at another example as we go along. One other example, let's just get rid of this here. One other example that we could have is 9 to the power 3 divided by 9 to the power -1. So we see those negative indices creeping up again in these questions. Now this is simply just a matter of employing the laws of indices, which states that when my base is the same and I am dividing, I therefore subtract my indices. Now in subtracting my indices, I notice here that I will be subtracting a -1, which means in essence it's 3 plus 1, which is 9 to the 4th. So the thing to look out with these questions is you are looking out for when there are negative indices and just being very careful when you're working with those. Okay, another question that we could look at here is 18 to the power of question mark, we don't know what that index is just yet, is equal to 1 over 18. Now, I do want to point out a few things here. This question is just asking you to figure out what is that question mark. Now, 18 as it stands by itself has an index or an exponent, but that exponent is not necessary and therefore not really seen. Now, the exponent that is understood, or the index that is understood, is, I hope you're guessing, 1. So that is really 1 over 18 to the power 1. Okay, now what power do I raise 18 to get 1 over? Now if you recall, the 1 over concept crept up when my exponent was a negative number. And it was negative of, and let's put that 1 over 18 there, it was the negative of whatever the positive exponent is in that question. So it's 18 to the power -1 is really 1 over 18 to the power of 1. But I know I don't need that, so I can get rid of that one really quickly. Oops. Let's get rid of that right there. Very good. So that one, that's another question down. We're going to be looking at another example, just a few more to go. 8 to the power of 1/2 to the power of 5. Now let me just get rid of some of this noise here. So 8 to the power of 1/2 is really, we know, the square root of 8, but we're not going to be using that at this time. We're going to be actually using the power to the power rule. When I have a power to a power, I know that I multiply those indices, and therefore this becomes 8 to the power of 1/2 times 5, which is really 8 to the power 5 over 2. And that's my final answer. Okay, now moving on, let's just do another example here. I'll leave that one for you to see. Our last example that we'll be looking at is Don't be intimidated by this one. So it's a to the power of 4, b to the power of a half, and that is all in brackets raised to the power of 6. Now it's a similar question to the one we just did, where it's a power to a power rule, which means that we're going to be looking at these as separate entities. So a to the power 4 to the power 6, and we're going to be looking at b to the power a half to the power 6. So we can pretty much condense that because we know we have to multiply our exponents there. That becomes a to the 24. And if we multiply our exponents there, that becomes b to the 3rd power. And that would be our final answer. So like I said, further index notation is just putting all the index laws together, all the little tips and tricks, throwing a few negatives in there. So just watch out for those. Best of luck with the exercise.